Yeah, hey everybody, Cam here again for another educational series video with myself. So a couple videos ago, we were talking about a concrete slab pour and the concrete trucks and the pump and the pump place finish and all that kind of stuff. Wanted today to go into a little bit more detail on concrete mix designs, as well as the testing that's required for the concrete that we get on site. So concrete mix designs, I mean, there's a lot of different concrete. I always talk about it as a Betty Crocker cake mix. So you got different pieces that go into it. You got rock, you got sand, water, cement powder, and then, some additives as well, water reducers, plasticizers, things like that. So a lot of different things that go into a concrete mix. And then specifically the usage of that mix. So if we're pouring a slab, typically we're using a larger rock. Here at RAM, we typically utilize a larger rock for the slab on grade mix, reduces cracking, easier to put down, that kind of stuff. If we're doing tilt-up panels, if we're doing footings and foundation walls, stuff like that, we're gonna be using like a regular kind of 20 millimeter aggregate. That being said, then it goes into some of those additives that I just talked about. So if you need it flowy, if you need the mix to be a little more soupy, you need more time to be able to work with it. We're looking at like a accelerator or even a retarder in order to slow the chemical reaction of the concrete down to be able to give you a little more time workability. A lot of times there's some areas where we can't pour it with a boom pump. Boom pump has a very large hose on it. Sometimes we have to use what's called a line pump. And so there's no actual boom to the concrete pump. It's just a hose that comes out of the back end of the hopper. Those hoses are typically a little bit smaller. And so the mix for those is even a little bit different with a smaller rock, smaller large aggregate size in it, usually a 14 mil or a 10 mil bird's eye aggregate inside of that, in order to allow the mix to be able to flow through that line. Typically in those scenarios, we're using a plasticizer as well. Plasticizer, like I said, is something that soups up the concrete a little bit without compromising the strength of the concrete. And so that's, a few different mixes that we use here at RAM. Obviously, always specified kind of by the engineer for the most part, and always signed off by the engineer. But I always try and do a little bit of tweaking to ensure that we're producing the best product and getting the best product that we can for the utilization that we need for it, right? So that leads into testing. So every concrete pour is tested. There's testing companies in the Lower Mainland that come and they do testing of the concrete. Testing of the concrete, you might be like, what is that? What are they testing for? Three main things they test for in concrete are the slump, the air content, and then obviously the strength of the concrete. So slump might be a word some of you might be like, what is he talking about? So the slump of the concrete is essentially the fluidity of the concrete. And so essentially the slump is measured in inches or millimeters, depending on how long you've been in the industry for and where you're located in the world. But slump refers to essentially how fast a cone-shaped cylinder of concrete sloughs down over a specified time period. I'm not a concrete tester, so I don't know the ins and outs of exactly how many minutes or seconds or something like that it goes into. But basically, they fill up a little cone with concrete, they flip it upside down, they rod it with like a piece of rebar or a stick for X amount of times, and then they measure the distance from the bottom to the top of it. How far it's gone down is what's referred to as the slump. There are CSA and ASTM standards that are in place to ensure that the slump is not too stiff or the concrete's not too stiff, or that the concrete's not too fluidity. Essentially, there's a range that you're allowed to be in order to maintain the strength of the concrete. Typically in Canada, CSA, ASTM standards, we're looking at an 80 millimeters plus or minus 30 millimeters. So essentially, it's allowed to gain or drop an inch based off of the specified slump that it's supposed to show up at. So that's kind of the slump test. Again, with a plasticizer or other additives, you can gain slump without actually compromising the structural integrity of the concrete. So We're looking at like a plasticizer that goes into it. We can get upwards of like a 130, 140, 150 slump without actually having to compromise and add too much water, which reduces the structural strength of the concrete. So a little thing on slump, you might hear it around the field. You might hear me talk about it randomly in some videos and things like that, but that's kind of what that's about. The next one they test for is air entrainment. So in all concrete mixes, there is what we call air entrainment. So they're basically microscopic air bubbles in the concrete. Different usages for this pertaining to high air entrained concrete, so a 5 to 8% air or a 4 to 7% air, is for like exterior concrete. So if you're doing a retaining wall, exterior footings, architectural concrete on the outside, things that are exposed to the elements, these microscopic air bubbles actually allow for when there's a freeze and thaw in the environment, it allows for if there's any water that's encapsulated within the concrete, it allows for that to freeze and thaw, the shrink and contraction and the expansion. It allows for that without actually compromising the structural integrity of the concrete. So air entrainment is a big one. For exterior concrete, you always want to have air in it in order to just made so it doesn't crack, basically. For interior concrete, you don't want air. So we're looking at usually like a 1 to 4% air entrainment content for the interior concrete. Air entrainment on interior concrete is a big deal because you cannot steel trowel or like power trowel or like polish essentially the surface of the concrete if there's air entrainment in the concrete above like a 4 to 5%. Anything above that and you'll get what's called spalling, flashback to our definition series, of the surface of the concrete. Essentially, when you power trowel that surface, you're burning the cream, you're polishing the cream that's right on the surface of the concrete. What happens when you have air in there is actually the air bubbles all end up coming up to the surface as well, and they create a bit of like a pocket below that polished crust area, which isn't good because then you end up getting a delamination between your polished surface and the actual structural concrete below, and so you'll end up getting spalling off the top of the slab. So that's another major one that we look for. We want to ensure that the air content is correct. For exterior works, you're looking for a 4 to 7, 5 to 8% air. Interior concrete works, you want it, 1 to 4. Typically on the lower end is obviously better to reduce the potential for that spalling and chipping and delamination essentially. It's not good, so always look out for that. And then the third one they test for is the strength. So concrete strength, some of you have probably heard, some of you might not have, but there's it's measured in MPa. So in Canada, we measure it in MPa. Our friends to the south measure it in PSI. I still don't know what the relation is. I could probably ask ChatGPT, but regardless, MPa up in Canada, footings are, the 25 MPa, 30 MPa, which is a typical kind of strength. You get into some of the, slab on grades with some vehicular traffic, maybe some racking. We got to boost that MPa up to potentially 32, 35. You look around town, we have towers, high-rise towers and things like that. Some of those guys are running 45, 50 MPa on columns, core footings, core walls, things like that. Fun fact, sometimes they actually color those special mixes in some of the high-rise towers. So you'll have like a red batch of concrete that is specifically 50 MPa that goes around kind of maybe like the bottom of where a column's gonna start in a footing or a slab. So fun fact on that one. And so how they test for this is they actually, they pour concrete into these cylinders. And so we get cylinders. In tilt-up construction, we actually, when we're doing tilt panels, we get cylinders and we get beams. In typical construction, for the most part, it's all just cylinders. The cylinders are, they're like 3 inches around, usually about a foot high, and they fill them up with concrete, and they are required to be field cured, so they have to stay on site for a certain amount of time, and then they're brought into the lab for testing. And so essentially, when they test them, they put them in a press and they break them, and the MPa strength that it's at the time is the MPa strength it takes to break that cylinder. You usually do what's called a 7-day test, and you'll do a 28-day test. The specified concrete strength that you're getting from a supplier, so a ready-mix supplier, that specified strength on that mix design that we just talked about would be the 28-day strength. The 7-day strength is where it's at. You usually see a bit of a curve where it comes up. Concrete never stops curing, so it'll continue up on that upward trajectory forever. An old saying goes, old concrete's harder than new concrete, but it's true. It just continues to get hard. And so the 7-day strength, the 28-day strength, within the structural aspect of concrete, so we're talking about, let's say, towers, specifically on our end, tilt-up stuff. Typically, you got to keep going with construction. Sometimes you actually have to use the concrete that you just poured to do something else. High-rise tower, we're talking pulling tables. We're talking taking shoring out. Tilt-up construction, we're talking about lifting panels. Suspended slab, same thing, taking shoring out, stuff like that. And so there's usually a specified strength that's required to do those things. And so sometimes people will, if they're on a tight schedule, they'll actually look at putting like a high early, more cement powder potentially in the concrete mix in order to gain that strength earlier than 7 days, in order to, let's say on a tower, if they have a 4-day turnaround for tables, they're able to drop those tables after 4 days because they've met that specified strength by the engineer. So just depending on what MPA is required for that, a lot of guys will sometimes test early to see if they've hit it or not. In tilt-up construction, we also do beams. And so beams are basically a rectangular mold that they pour concrete into, and it measures the flex. And so a big thing on our tilt-up panels is when we're lifting the panels, a lot of times they flex a little bit. Obviously, big, long, wide panel, concrete does have the ability to flex a little bit. So with these rectangular things, same thing, they're field cured for X amount of days, brought into the lab, and then they're given a little push on one end over the end of a table to see how far they flex. That's a big one because we want to ensure that panel doesn't incur any cracking when it's being lifted. We don't want any surface cracking on the outside of the tilt panel. We don't want any structural cracking, any of that kind of stuff. So it's got to hit the MPA and it's got to hit the flex for us to be able to lift those tilt panels. And so then with regards to the MPA, same thing as I was just talking about with towers and suspended slabs and things like that. With tilt panels, if we're on a tight schedule and let's say we have the crane coming in on Monday and we just poured on Thursday, we may do some things as to the mix design in order to boost that 7-day MPA so that we can maybe get that 7-day required MPA that we need to lift the tilt panels in a 3-day thing or a 4-day thing, just pending on scheduling and things like that. Obviously, always run past the engineer. Specified strength is something that nobody plays around with, and it's got to be there. But there's ways of achieving that. So a little bit about concrete mixes, a little bit about concrete testing. Exciting stuff. As you can tell, I get super passionate, a little bit nerdy on it. But it's it's exciting stuff, and it's the backbone of the building, I find, and it is very interesting. So appreciate you guys listening, and look forward to chatting with you on another education series with Cam. Take care. Cheers.